Now that you know what variables are, it's time to start learning about a few specific classes of variables. In this lecture, I'll focus on variables that are used to store numbers or collections of numbers. The goals for this video are to introduce you to scalars, vectors, and matrices, show you how to create them and how to work with them, and I'll also show you how to use the colon operator to index parts of vectors or matrices. So, a scalar is just a single number. It's called scalar because single numbers are used in geometry and in linear algebra to stretch or shrink vectors without changing their direction. I'm not going to go into detail about that here, but you just need to know that when someone says scalar in MATLAB, they're referring to a single number. Assigning a scalar to a variable is easy, and I showed that in the previous video. You just write the variable name equals the number like this. X equals 10. A vector is an ordered list of numbers. To create a vector, you need to concatenate the numbers, and that's done with square brackets like you see here. So here I create a vector of 3 numbers using square brackets. And now we have this vector. Vectors can be flat across like this one here, or they can be standing up. A long flat vector like this one is called a row vector, and a tall vector is called a column vector. If you create vectors the way I showed you here, they will always be row vectors. So there's 2 ways to create a column vector from a row vector. One is to transpose the row vector using the single apostrophe here. Transpose means to flip the vector. So now we get a column vector. A second way is to put semicolons between each of the numbers, and that's what we do here. Notice that this is a different way of using semicolon compared to suppressing the output at the end of a line of code. So here's a question for you. Which of these semicolons are necessary and which are optional? You can use the colon operator to create a vector. That's as simple as using the colon operator the way I showed in the previous video and then setting it equal to some variable. So here I'll create a vector to go from 1 to 9 in steps of 2, and I set it equal to this vector called skipVec. Notice that this is a row vector. How could we make this into a column vector? You might think of transposing like I showed a minute ago, something like this. However, that still gives a row vector. It has no effect. In fact, what's actually happening is that MATLAB is transposing only the final number, 9. And transposing a scalar has no effect because it's just a number whether you read it down or across. So instead, what you need to do is put the entire colon statement around parentheses, and then you transpose that. And then we get a column vector. Or you could have created the variable as a row vector and then set it equal to itself, transposed. This would have the same effect. So, we went from scalars to vectors, and now the next step is to go from vectors to matrices. While a vector is a list of numbers in a line, a matrix is a collection of numbers organized like a spreadsheet with rows and columns. Matrices are used all the time in MATLAB, linear algebra, mathematics, physics, engineering, you name it, matrices are all over the place. Matrices can be used to store data or store images. They can represent transformations or control operations. They represent systems of equations, and they can be used to implement signal processing techniques like convolution or the Fourier transform. So, to create a matrix in MATLAB, use square brackets in combination with semicolons to indicate breaks between rows. So here we have the square brackets, and here we have a semicolon each time I want to add a new row. So this ends up being the first row, the second row, and the third row. So we can see what this looks like. Here I've created our 3 by 3 matrix. You can also transpose a matrix, which has the effect of making the rows columns and the columns rows. So note the difference between this matrix and this matrix. You can see it's transposed, so here the column 193 became the row 193. In matrices, the number of elements in each row has to be the same. This can lead to a mistake or an error when creating matrices. You can see here that I've removed one of the numbers, and now, so MATLAB is already underlining it in red. We'll talk about that sort of behavior in more detail in the future, but basically it means that MATLAB is telling you that there's an error. And the error message here says all matrix rows must have the same length. So we can try running this line of code, and unfortunately it does not work. Let's look at the variables we've created so far. I'll type whose, or you can look in the workspace window if you prefer doing it that way. This column tells us the size of each variable. That's important information, and it's usually the first thing I look at when I'm inspecting the workspace, in particular when I'm debugging. So now you know how to create numeric variables, but these vectors and matrices can get really big. And what do you do if you want to access not the entire vector, but only part of a vector? That's done through something called indexing. So we can index a single element of a vector using parentheses and the number that you want to index. So vec is the vector 1, 4, 3, and when I type vec parenthesis 2, I'm asking MATLAB to tell me only the second element in the vector vec, which is the number 4. One common type of error is to index using a fraction or a decimal, and this doesn't make any sense because there's no such thing as the 0.4th element in a vector. In addition to accessing single elements of vectors, you can also access multiple elements using the colon operator. So the colon operator here, the way I'm using it here, it's going to return 2, 3. And then when I embed this inside the vec variable name using parentheses, the result is going to be the second and the third elements of the vector vec. Another type of error that often happens with indexing is if you try to index an element of the vector that doesn't exist. So vec has 3 elements, and if I try to access the 4th element, MATLAB is not going to be happy about that because there is no 4th element of this vector. What do you think will happen if we try to use the colon operator to access elements 1, skip 0.5, skip 2? It probably should give an error because there is no 1.5th element of the vector. However, if you run this in MATLAB, you actually will get a result. It's 144, and you'll get a warning message. I should mention that this behavior is MATLAB version dependent. So it's possible that in your version of MATLAB or Octave, this will actually give an error, not a warning. And if you look at what's happening, MATLAB is actually rounding the indexing. So it rounds this up to 2, and then it gives us the first element, the second element, and the second element again. You will also get an error if you try to access the 0th element of a vector, or if you try to access a negative element of a vector. The colon operator is one way to access multiple elements from a vector. Another way is to use square brackets and indicate exactly the elements you want to access. The advantage of this method is that you can access any arbitrary sequence of indices. They don't have to be regularly sequenced. So here, for example, I'm going to access these elements of vector vec. And there are repeated elements, and they're not presented in any special order. Indexing matrices is similar, but there's an added layer of complexity, and that is that you have to access each dimension of the matrix separately. So let's see an example. This matrix, MAT, is 3 by 3, and let's say I want to access the first row and the second and third columns. So I type MAT and then the first row and the second and third columns. Alternatively, I could have typed like this with square brackets. Notice that I'm accessing each dimension of the matrix separately using a comma in between the dimensions. So the rows, comma, and then the columns. That's really important because if you would type something like this, MAT 4-5, you might initially think that that should give an error because neither the rows nor the columns have elements 4-5. However, this will actually work in MATLAB due to something called linear indexing. Linear indexing can be a powerful way to access elements of a matrix. However, it can also be very confusing. I recommend avoiding linear indexing until you become more familiar with MATLAB. Let's recap. The main topic here was using variables to store numbers. These are called numeric variables. I introduced you to scalars, vectors, and matrices. I showed you how to create vectors and matrices. I showed you the transpose operator to flip rows into columns. And I showed you two different methods for accessing parts of vectors and matrices. One was using the colon operator, and a second was indexing them directly using square brackets.